Yeah, that's all. No, I can record. All right, so a which question are you talking? Which one? Well, yeah, which question? Like which part of 10? You said something about equations, but which part are you confused on? Oh, hello? Do you have a so let's see. Like specifically which equation to use on which part? They just mean
I'll just speak on this one.
okay. I can hear you.
Okay. Uh, oh yeah, hold on. My computer is kind of being slow right now, so it's hard to. Yeah, usually I get confused on using the equations.
Okay. So is
Like
that B? No. Is
yeah,
it?
or I'm trying to load up the thing right now. Yeah, sorry, it kicked me out.
Out of what? AP Classroom?
Yeah.
That's fine. So let's see. Okay, looks like A is just drawing. So we can go over the whole thing on number 10. So we have a robot, and the robot shoots a large sphere of mass m in the horizontal direction with a variable speed and from a variable vertical position and a fixed horizontal position x equals 0. The robot is calibrated by adjusting the speed at which the sphere is launched and the height of the robot's sphere launcher. Depending on where the spheres land on the ground, students will earn points based on the accuracy of the robot. The robot is calibrated so that when the spheres are launched from a vertical position y equals h and speed v naught, they consistently land on the ground on a target that is at position x equals d. Positive directions for vector quantities are indicated in the figure. And so on A, we have to sketch the horizontal and vertical components of the sphere's velocity. So here we go. So let's say this is Vx. And let's say this one is Vy. And we have T. And we have to label capital T for the horizontal component of the sphere's velocity and the vertical component. All right. So capital T is when it hits the ground. All right. So when you're solving this problem, the robot is shooting the ball like fully horizontally, right? Which means if you have a fully horizontally shot ball, then the initial velocity in the x direction should equal v naught, right? Let's pretend that's straight.
Abby,
Oh, hi, Lexi. We're going over number 10. And so, all right, one second, let me see. All right, exactly. So V naught is going to be constant because there's no acceleration in the x direction that you are going to account for. So it's not going to change. Does that make sense? That one's kind of easier to look at. So y, Vy, however, this is one that needs a little conceptual thinking. Vy, notice how they say the ball is shot horizontally. That means that's not shot up or down, which means that Vy has to start at 0 because it's not being shot upwards or downwards, if that makes sense. And because gravity continuously affects the sphere, the velocity of the sphere should go down continuously until it reaches a certain point. All right, and the point at which it hits the ground, that will be T, capital T. I just wanted you to label that. Does that make sense, Zach?
Yeah, so far.
Yeah. And basically, some like extra bonus things that you could see is that the area under the curve of this y graph is the height h. So the area under the curve of the Vy is height h. And the area under the curve of Vx is distance d. And that makes sense because the area under the curve of velocity is like the total distance traveled, and it's traveled d distance before it hit the ground. And it's also traveled h distance downwards, so negative h distance. Okay, and for B, I don't think we actually have any equations here. In a clear, coherent paragraph length response that may also contain diagrams or equations. Okay, I guess there's equations there. So, all right, Zach, basically putting it out there for B. So the only thing that's changing is y equals h has gone to y equals h divided by 2, right? That's what the question says, if you have it in front of you. The sphere may be launched at either v or 2v. All right. So this makes sense so far? I just wrote down the things in the question. Everything good? Oh, okay, he's typing in chat. Okay. So essentially, in your explanation, you want to include as many logical things as you can come up with. So when you decrease the height, h divided by 2, what happens to the time it's in the air? What do you think happens? What do you think happens to the time it's in the air if you divide it by 2? Like it's not a trick question with many equations, because remember that, remember basically, like, I don't know how to put this, but you would write the kinematic equation, right? So y final equals y initial plus v initial times t plus 1/2 negative a, and then t squared. So that's what you have. And essentially y final is 0 in both cases, right? So this is original. So if we go to the original, can I do this? Wait, Lord. If we go to the original, 0 equals h plus 0 plus -5 times t squared meters per second squared. I should make that longer. I can't type LaTeX here. And the adjusted, we have 0 equals h divided by 2 plus -5 t squared meters per second. I'm just going to remove the meters per second squared for clarification. All right, we have that, right? And so basically, if you solve for t in a way, you would get that basically the time is half. You could go in half the time, in a fraction of the time. It said, remember it says that the students can earn the maximum number of points in the competition. It's not exactly half the time. So if you solve this out, what would it be? It'd be like h divided by 2 divided by -5. So h divided by -10 square root compared to h divided by -5 square root. So you'd want to, essentially, you need to determine whether, what is it? Whether t is close to, can I draw? Whether t is closer to 1/2, like t new, t prime, is closer to 1/2 t, or if it's closer to a different number, which is, would be less, if t prime is less than 1/2. You know, that's kind of confusing to say. Does that make sense though? Let me find the key here. So for these kinds of questions, I would just write down the most amount of things you can identify. So let me just show you basically what you want to find out is list the things we know. If you put it at half the height, does it fall in fast? Does it hit the ground faster or slower? Like obviously it would hit the ground faster, right? If you put it at half the height, that should make sense. So we also know that if we shoot the ball at v naught, the original, it would go less distance. All right. And then we know that, let's see. We also know that no matter what velocity we choose, we cannot get 4 points. If you think I'm pulling that out of nowhere, it's because 4 points is in the picture. It says if you hit the target on spot, you get 4 points. Let's see, where's my all right. They should aim, and remember, and the logic, and this logic is, if you shoot at v naught, you get less than d. But if you shoot to v naught, you may go over d. So since over d has a 3-point zone, the students should shoot at 2 v naught. That's that's like the logic behind the question. Please stop. All right, that's 1 point. That's another point right there. All right, does that make sense? This is just logical things you could find in the real world. If you lower the if you pitch a ball horizontally at a lower height, it'll hit the ground faster, obviously, because it's less high. You can't get a perfect score because if you work it through the kinematic equations, time would not equal, like time, you can't get time, which is square rooted, to be equal to 1/2. Okay, there was an announcement, but it's good news. But yeah, if you shoot at V naught, if you shoot at the original speed, since it has less airtime, it'll get lower. It'll hit the ground before D, and if you go faster, it could go beyond D. So what you do is you shoot at 2 V naught since it has the higher chance. All right, that's number 10. Do you guys have any other questions? All right, Lexi's pulling it out. You can feel free to type in chat if you need.
So for the first question, number 1, with the car in like the circle, what does it mean where it says the car has no self-propulsion?
Ah, yes. So when in number 1, when the toy car says it has no self-propulsion, that means that it doesn't have any acceleration.
Oh, okay.
So like if you step on the gas, you accelerate, so you have an acceleration. But this toy car has no acceleration, it just has the velocity it was initially going at.
So the car's
Wait,
acceleration.
this question is I should never give you this question. I'm not gonna count this question against you.
Okay.
Because yeah, you're right. I'm surprised nobody else asked me about it.
I was just confused because I wasn't sure if it was asking about the direction of the acceleration vector or the direction of the velocity.
If you have the loop, right, and then it's asking about the acceleration, when the car is exactly at point P, what acceleration, what forces are acting upon the car? What direction are the acceleration vectors? Well, what's one that you could name?
Gravity.
Yeah, gravity. So there's acceleration downwards, right? And something that you're supposed to know in unit 3 is that if anything's traveling in a circular motion, the acceleration is always towards the center of the circle. So the answer would be D. It has components downward and towards the center of the circle. I don't know how that slipped me. I only picked like multiple choice that said unit 1. How does that get by me? All right.
And then the other one I had for 2, it was just the area under the curve, right? Or like
well, let's look at 2.
Okay.
An object is sliding right along in a straight line along a horizontal surface. The graph shows the object's velocity as a function of time. What is the object's displacement during the time depicted in the graph? All right. So it's not asking how much distance the object has traveled. It's asking specifically for displacement. You remember in my notes, displacement is a vector. So it's the shortest line between point A and point B, whereas distance is the total amount of distance traveled. It's like, how much have you truly moved, right? If I walk in a complete circle in a forest, I've displaced 0 meters because I came back to the same spot.
Okay.
Well, because velocity is positive, if you take the area under the curve, you can find the distance it's traveled. And on the left side before 4 seconds, right? Let's see, I can draw this out.
Yeah.
Yeah, 4. And then 4 here. And it does something like this, right? Oh, yeah, negative 4. And then you have 4 seconds here. And it does something jank like this.
Yes.
Perfect. And this is 8. So if you take the area under the curve, you can see that 4 times 4 divided by 2 is 4. No, 8. 8. I'm embarrassing myself on camera. But that's above the x-axis, right? So that's
Mhm.
positive 8. And then this is 8 units below the x-axis. So this is negative 8. So 8 minus 8 is 0. The displacement is 0 because the toy went forward, like forward, slowed down a little, and then it ended up going backwards. So like, let me depict you a real life scenario where this could happen, because I like to picture things in real life scenarios as how they could happen. This velocity versus time graph could occur. Let's say it's easier for me to picture it in the X. Let's say there was a toy car, right? Or no, there's a ball rolling. There's a ball rolling at 4 meters per second, right? And then a gust of wind pushed the ball 1 meters per second squared backwards, right? So that gust of wind is going to slow the ball down, right? And at some point, it's actually going to stop the ball. After 4 seconds, it'll stop the ball, and then it'll roll it backward, right? So after 8 seconds, that ball didn't go anywhere. That's what that means. The distance the ball traveled is 16 meters. What's the difference? Distance is a scalar that just depicts how far something has traveled, like, entirely. Displacement is a vector that is the line you can draw between point A and point B that's the shortest distance from it, if that makes sense.
Yeah. Mhm.
All right. Zach, how are you following along? Any like questions to interject in? By the way, the reason I look towards this direction so much is because I have a second monitor here. If you have never tried a second monitor, it's like God's gift to humanity. Like, and every monitor you add onto that is like an addiction. Like, you can't. It was just number 10. All right, yeah. You can feel free to like leave and then check out the recording later, or you can stick around if you have any other questions that might come up. All right. Do you guys have any other questions?
The last one I kind of like guessed on was 5.
5.
I wasn't really sure.
Okay, let's see. 2
Um,
students want to determine the speed at which the ball is released when thrown vertically upward in the air. One student throws the ball into the air while the other student measures the total time the ball is in the air. They use a meter stick to measure the release height of the ball. Which of the following equations should the students use to determine the speed at which the ball was released? Okay. To determine the initial velocity of the ball. Well, there is like technically like multiple ways they could do this, but I would, oh, I'm not selecting answers. I would look at this. Do we know the final velocity of the ball? No, right? Because the ball is falling, and the moment it hits the dude's hand, it will become 0 due to forces. But like the instant before it hits the dude's hand, we don't know the final velocity, right? So we can't use C. We can rule out C and D immediately because we don't know the final velocity. Now, then on the flip side, what is the reasons that we use A and B? Well, we have the initial height, which is why not. We have we want the initial velocity, right? So that's one we don't know. We don't know the time. Okay, that's cool. We don't know the time. Oh no, wait, sorry. We do know the time because we had a student. Yeah, a student measured the total. Okay, we have the time. We have the acceleration. It's gravity, and we have the final position. It returns to his hand, right? It returns. So therefore, the initial and final position are the same height, if that makes sense. Because of that, we can use A and B, the kinematic equations 2 listed in A and B, to find it. And so we can, oh, Yeah, we have to use B. Between A and B, we use B. Now let me explain to you why.
Okay. Because I chose A. I wasn't.
Yeah. Let me explain why we can't use A. Technically, you have everything to solve for, but I mean, this is AP. They don't want to ask you to in a specific way. So you have the dude's hand, right?
Mhm.
Yeah, that's as malnourished as it's gonna get. And we have a ball cupcake at this point, and it's going up. And so the path that the ball follows here in blue will be like this. It'll just go straight up, and then I'm gonna assume he moved his hand, and it'll go down and hit the ground. Right? We have why not, right? And this H, and this is 0. Y final equals 0. Now let's read what A says. A says, from the moment in time which the ball was released to the moment in time which the ball reaches its highest point. Yeah. So it means from here all the way to here. Actually, let me. Okay. Now, Lexi, you can technically find, if you had everything, right? If you had everything, you could technically find the speed with this, but let me tell you the reason why you can't. You don't have the Y final if you use the highest point.
Okay.
For A, you don't have Y final equals question mark. Why? Because it says in the problem, the student uses a meter stick to measure the release height of the ball, not the final height of the ball. So you wouldn't have Y final. It's like this problem is more like a small thing you were supposed to catch. But if you do it to which the ball hits the ground, you can use Y final equals 0 and you can solve it. Does that make sense? It's not that you didn't understand how to use the equation. It's that you didn't read the question extremely carefully to the point, to the degree they wanted you to.
Okay.
So yeah, if you did have the final height of the ball, I guarantee you could find the initial velocity. But because the student never measured it, we don't know. That's how it be. That make sense? Yep. Awesome. All right. Any other questions?
I think that's it.
That's it.
Yeah.
I'll wait here, and if anyone else comes, I will answer their question, and it'll be on recording, so you guys can watch that. Did you guys catch see the recording, or could you access the recording of yesterday's?
Did you post it somewhere?
Yeah. So in Google Classroom materials, no, not materials, resources, it says 9:10 office hours, and it's a 45-minute YouTube video, but please just skip around till I start talking about an actual problem. I told the exact times of the problem. So yeah, you want to look at that at like double or quadruple speed until I start talking about like the actual problem. Totally good. Totally up to you. Yeah, and anytime. And I think I'm planning to get the swivel. So it might be, class might look different now because I might just straight up teach all the material and have you watch a video of me teaching the class. So that might be how it goes. I'll still have to figure it out and play around with it. But look forward to that. We'll see about it. All right. Great. So if you guys don't have any other questions, I'm not holding you hostage. Nobody's holding you hostage. You can hold me hostage though. Until 2.
Yeah. Most of the other problems was just like the equations and using the
I just exited out of my page.
Yeah, I think the only other questions other than 1 and 8, I'm looking through these. I don't think there's any ones that you guys should be able to solve other than 1 and 8. I don't expect, if nobody looks at the videos, I don't expect anyone to get 1 right. But that's okay. I don't count it against you. All right. Zach, you good? All right, you guys can feel free to leave.
Thank you.
I will stop the recording somehow.
All right.